Hello, today we're going to talk about topic 3.3, which is finding missing factors and greatest common factors. So the way we find a missing factor in this first section right here, you've got something in this set of parentheses multiplied by 6am squared m to the 7th is equal to 24a to the 5th m to the 9th. Well, let's just make this simple and go up here and let me just say, if you had that 3x equals 24, you would know that you needed to divide by 3 in order to determine that x was 8. This 3 over 3 becomes 1. Well, you're going to do the same thing to find this missing factor. It's just that the division's a little more complicated. We can think of this as our x. This is what we're looking for, what we don't know. We need to divide it by the coefficient, but because what's in front of this, there's a number behind this a and a number behind this m, if you want to think of it that way. So when I multiplied all that together, if I knew what a and m were, then I would find a constant or a coefficient. It's just written as 6 times a squared times m to the 7th. So I'm going to divide by 6a squared m to the 7th on both sides. Okay. Now, that means anything over itself is 1, so all this divides to be 1. So now I have x, or whatever that question mark is. X is, and you do your division like we've been doing now for the past couple of days. 24 divided by 6 is 4. A to the 5th over a squared is a to the 5 minus 2. And m to the 9th over m 7th is m to the 9 minus 7. So my final answer is going to be 4 a to the 3rd m squared. And then that's my final answer. That's what would go in this parentheses right here. And so if you think about it, I'm going to erase that if I can. Right there. Okay. And then this would go into that set of parentheses. And so if I multiply 6a squared m to the 7th by 4a cubed m squared, I should get 24a to the 5th m to the 9th, and you find out if you do that in fact it comes out. So it doesn't hurt, certainly doesn't hurt to check. Looking at number 2, it's the same situation. I want to know what's in this set of parentheses. So I'm going to leave that alone by itself, and because this is multiplied, there's no plus or minus sign in between it. It's this set of parentheses, 5x cubed y, times this set of parentheses. So I'm going to divide by 5x cubed y, and divide this side by 5x cubed y. Okay. Now do the division. Negative 5 divided by 5 is negative 5. X to the 4th divided by x cubed is x to the 4 minus 3. And y to the 6 over y is y to the 6 minus 1. And so that comes out to be negative 5 x to the 1st, which I just write x, and y to the 5th. Okay. So multiply this by our original equation. 5 times 5 is negative 25. X cubed times x is x to the 4th. And y times y to the 5th is y to the 6th. It checks out. So this is my final answer. Okay. Now, when you have something like this, I've got 3 things multiplied together. So first you need to multiply these two sets of parentheses. So we'll have 30 a to the 6th, b 5th equals 2 times 10, 5 is negative 10, a times a squared is a cubed, and then b times b cubed is b to the 4th. And then I have, trying to figure out what should be in that set of parentheses, so that all three multiplied together give me 30a to the 6th, b to the 5th. So I'm going to divide by negative 10a cubed, b to the 4th on both sides. Okay, and then 30 divided by negative 10, negative 3, a to the 6 minus 3, and b to the 5 minus 4. So my final answer then will be negative 3, a to the 3rd, b. And you can double check. Negative 2 times 5 is negative 10 times negative 3 is positive 30. A to the 1, 2, 3, 4, 5, 6. B to the 1, 4, 5. It comes out. Okay. That's finding the missing factor that you'll have to do on your homework. Finding the greatest common factor. You have to look at these two terms, these two monomials, and tell me what they have in common. What do both of them have? Well, you can break it down. X to the 5th is x times x times x times x times x. And then x to the 3rd is x times x times x. So we see they both have 3 x's. X to the 5th has 2 more, but this one only has 3. So what they have in common is x cubed. That's the greatest common factor. Okay, now some of you are going to be able to see this very quickly and do it without any trouble, and some of you are going to have to spread them out like this and look. So let's do this one. Let's go ahead. We have x times y times y times y times y. That's our x squared y cubed. Now that we have an x to the 5th, x times x times x times x times x. And we have times y, because that term is x to the 5th y cubed. So there's 5 x's and 2 y's. All right, what do they have in common? This one has 2 x's, and this one has more than 2, but it has 2. So all they can have in common is 2. You can't have more than any one of them has. This one has 2 y's, this term. This one up here has 3, so they share. They both have 2 because it's the factor they have in common. So both of them have 2 x's and 2 y's, so the GCF is x squared y squared. Okay. And that's what you're trying to find, the greatest common factor. All right, now think of numbers. You've done this from elementary school where you found the greatest common factor of sets of numbers. So we have 16 and we have 20. What number will go into both of them? What number do they have in common? 16 is 4 times 4, and 20 is 4 times 5. Is there anything else that you can think of that would go? I don't think of anything. So I'm thinking that the number that they have in common is a 4. This has 2 m's, m squared. This has 3 m's, m cubed. So the most m's that they have in common is m squared. And so the GCF is equal to 4m squared. Now you could go and you could do the prime factorization. 16 is 2 times 2 times 2 times 2 And 20 is 2 times 2 times 5. And find out, just like we did with the letters, that the number they have in common is 4. And then the 2 m's and the 3 m's, just like we spread them out of here. If you need to do that, the prime factorization using a factor tree or whatever you've been taught to do, then go ahead and do that. Some are going to be harder to figure out than others. Let's look at 56 and 32. 56, 8 times 7 is 56. 32, 8 times 4 is 32. So our greatest common factor in terms of numbers is going to be 8. Then they both have a c cubed, so they have c cubed in common. This one has a d squared, but there's no d over here with the 32, so they don't have d's in common. And by the same token, this has an e squared, but over here there are no e's. So they don't have an e in common. What they share is 8 c cubed, and so that would be the greatest common factor for these two terms. Okay. And my F looks a little weird there. Okay. So that covers that little piece of this topic. Now I'm going to click on the mouse, which will make all the writing go away, and move it down to the next page. See if I can get there. Okay. All right. In number 8, we have 3 terms. So it's a little more difficult, but we just look at all of them. 12 is 2 times 3 times 2, or 6 times 2. 14 is 2 times 7. 15 is 3 times 5. So there's not a number that all 3 of them have in common. This first 2 have 2's, the first and the third have 3's. Not only this one has a 5 and only this one has a 7. So there's no number that all of them have in common. So we can't include a number in our greatest common factor. So now let's look at the letters. We have x to the 5th, x cubed, and x squared. So the most x's they have in common is right here, the x squared. They all have at least 2 x's. How many y's? We have 2 here, 4 here, 3 here. So the most y's that any of them have is y squared. So they all have at least 2 y's. So we put a y squared as our greatest common factor. And they all have at least 1 z. This one has 3 and this one has 4, but this one only has 1. So for a common factor, they only have 1 z that they all have. And so that would be our greatest common factor for that set of 3 terms. Now the last part of this lecture is review, things you might expect to see on the homework or the test, trying to keep you up to date on things you've learned in the past. And so that's all we have in terms of the greatest common factor. This example, the line has an x-intercept of -12 and a y-intercept of 6. Write the equation of the line in slope-intercept form. In slope-intercept form, which you should remember is y equals mx plus b. All right, so let's just sketch this. X-intercept of -12 is going to be over here, and that's a point. And the point then is -12, 0. And it has a y-intercept up here of 6, and that is 0, 6. So just from this quick sketch of the line, it is going to have a positive slope. Now we need to figure out the slope of the line for slope-intercept form. So we've got 2 points now, and that's one reason it helps to plot it on a graph. Okay, we can name this one x1 and y1, and this x2 and y2. And if you remember, your slope formula is y2 minus y1 over x2 minus x1. So y2 minus y1, I should have put a 1 there. Okay, so we have 0 minus 6, if we go do them as they're labeled. And then we have negative 12 minus 0. And then that ends up to be negative 6 over negative 12. Negative over negative is going to be positive 1/2 when I reduce the fraction. Now this is easy once we find the slope because we already know the y-intercept. And if you remember, m is the slope right here, d is the y-intercept. So the equation of my line then is y equals 1/2 x, just put the slope in there, plus the y-intercept, which is 6. You don't have to do any more calculations in this particular problem. Now number 10 is one that seems to always throw people when we do these. It's the idea of the perpendicular line. Remember, we used this equation just to find the slope of our new line. So let's solve this for y. So when we'll say we'll subtract x from both sides. Okay, now I already did that. I subtracted x from both sides. And this is what I ended up with. Now I need to be y equals mx plus b, so I'm going to divide everything by negative 3. This becomes just 1y. Negative over negative is positive, so it's 1/3 x plus, whoop, there's a negative, so it's not going to be plus, it's going to be minus. 12 divided by negative 3 is minus 4. Now again, like I told you before, all I need from this is the slope. The slope of this line is 1/3. The slope then of my new line, which is perpendicular to that, is the negative reciprocal. So you change the sign and you flip the fraction over. So instead of 1/3, it's 3 over 1, or just negative 3. Now I need the point. Now I've got my slope, and I need this point, and I put it in point slope form, which is y minus y1 is equal to m times x minus x1. Okay. So y is negative 11. Y minus negative 11 is equal to negative 3. That's my slope from right here. And I have x minus 3. And this is my, in case you're wondering, this is my x1 and my y1. So y plus 11 is equal to negative 3x plus 9. Negative 3x, and negative 3 times negative 3 is plus 9. Subtract 11 from both sides. So y equals negative 3x, and 9 minus 11 is minus 2. Okay. And that would be the line that would be perpendicular to x minus 3 equals 12, but goes through this point. And you could graph it and verify that. Okay, I don't think there's any more problems on the page, but I'm going to pull it down and see. I'm going to click the mouse. Okay. No, that will finish us up for today for the lesson. This lesson was done on Thursday, the 9th, 2012, February 9th, for those of you that were absent on the field trip.